All right, let's talk about artificial intelligence. It's this massive, kind of intimidating topic, right? But what if we could actually build it from the ground up, piece by piece? Well, that's exactly what we're going to do today. We're using the legendary textbook, AI, A Modern Approach, as our guide to create a blueprint for intelligence itself. So let's get right to it. What is AI really? And I mean, let's forget the sci-fi movies for a second. We're going to dive into the core engineering of it. You see, the real goal isn't just to make a machine that thinks like a person, but to build something that can act rationally and effectively out there in the messy, real world. And here's our game plan. First, we're going to lay the foundation with something called the agent. Then, we'll start adding layers of skill, how it solves problems, how it deals with uncertainty, and maybe most important, how it learns. And then we'll put it all together and see how these parts make up the AI that is literally changing our world as we speak. Okay, let's get into part one. The big foundational idea in modern AI isn't some kind of brain in a jar. It's what we call an agent. And an agent is basically any system that is designed to perceive its environment and then act within it. So this is the concept that really unlocks everything else, an intelligent agent. Just think about a self-driving car. You've got its cameras and its lasers. Those are the sensors, and they're taking in everything about the world around it. Then you have the steering wheel, the brakes, the accelerator. Those are the actuators. That's how it acts on the world. That's really it. It perceives and it acts.
And this all happens in this constant loop. Let's take the book's super simple example, a robot vacuum. Its sensors spot some dirt, that's the perceive part. Its little program inside decides what to do. The vacuum motor, that's the actuator, kicks on and acts. And boom, the environment changes. The floor is now clean. Perceive, decide, act. That's the heartbeat of AI.
Now, the most basic, bare-bones version of this is what's called a simple reflex agent. It's pure stimulus response. There's no deep thought here. It's just a simple rule. If you see dirt, then turn on the vacuum. It's not planning for the future, it's just reacting. But believe it or not, this simple little behavior is the very first layer of intelligence in our blueprint. Okay, so reacting is one thing. But what if our agent needs to achieve a long-term goal? What if it needs a plan? Well, for that, we need to add a whole new capability, the ability to solve problems by searching for the best path to get there. So how does it find that path? Well, it could just try every single possible route. We call that uninformed brute force search. And as you can guess, it is incredibly slow and inefficient. The much, much smarter way is informed search, which uses a heuristic, and that's just a fancy word for an educated guess to figure out which paths seem most promising. Check out this classic example, trying to drive across Romania. An informed search isn't just going to wander around. From the starting city, Arad, it uses a heuristic, in this case, the straight line distance to the destination, Bucharest. It looks at its options and sees, Sibiu looks closer than the others, so it goes there. From Sibiu, it does it again. Făgăraș looks closer. It's a smart, efficient way to find a solution without exploring the entire country. All right, so now our agent can plan. That's great. But so far, we've assumed its world is perfectly neat and predictable. And we all know the real world is, well, it's messy. It's uncertain. To handle that, our agent needs a totally new tool. It has to move beyond black and white logic and start thinking in shades of gray, with probability.
And the book gives a perfect real-world example of this. A self-driving car sees red lights on the car in front of it. So, is that car braking hard? Or did the driver just turn on the headlights and the tail lights are on too? A simple if-then rule just can't solve this. The agent's perception of the world is fundamentally uncertain.
This is where probability theory comes in. It's basically a mathematical framework for managing uncertainty. So instead of knowing something is 100% true or 100% false, the agent can assign a degree of belief to it. It can say, you know what, I'm about 80% sure that car is braking.
And what this does is it lets the agent act like a detective, constantly updating its beliefs as new evidence comes in. It can weigh all the different clues and move from just thinking about what's possible to actually calculating what is most likely. And that leads to way smarter, way more robust decisions when things get fuzzy. So we have an agent that can plan and can handle uncertainty. Awesome! The final, core piece of our blueprint, the thing that really makes AI feel like AI, is the ability to learn, to actually get better at what it does over time all on its own. And one of the most powerful ways for an agent to learn is through something called reinforcement learning. You can think of it like the agent teaching itself through trial and error. It tries an action, and then the environment gives it feedback, either a reward, like a treat, or a punishment. And over time, it just learns which actions lead to the best rewards.
So imagine our agent is trying to solve a maze. For every single step it takes, it gets a tiny little punishment, a small negative reward. This basically encourages it to be efficient and to not just wander around aimlessly. But the moment it reaches the end of the maze, the goal, bam, it gets a huge positive reward. That's the jackpot it's been searching for.
So after doing this thousands, maybe millions of times, the agent starts to fine-tune its policy, its internal strategy, to figure out the series of moves that will get it the most reward in the long run. Its behavior literally evolves and becomes smarter and more effective at reaching its goals. Okay, so we've built our blueprint, we have an agent that can search for goals, that can navigate uncertainty, and that can learn from experience. Now, let's bring it all together and see how these fundamental pieces form the foundation of the absolutely incredible AI systems we see out in the world today.
And this isn't just theory, right? These concepts are the engine behind the AI that's everywhere. They power the robots in factories, they're inside the language models that can write poetry or translate languages. They allow computers to see and understand what's in a picture, and they've even led to AIs that can beat the best human players at unbelievably complex games like Go.
And the pace of progress has just been staggering. I mean, look at this. On really specific, hard tasks like question answering, AI systems went from performing way below the human level to actually exceeding human performance in just a handful of years. It's an incredible explosion of capability.
Which brings us to a really crucial shift that's happening in AI research right now. As the book points out, we're moving away from building systems where we just give them a fixed goal, like win this game of chess. Now the frontier is building systems that have to operate while being uncertain about what we, the humans, actually want them to do. And that leaves us with maybe the most important question for the future of all of this. We've designed an agent that is absolutely brilliant at learning and optimizing for whatever goal we give it. But what happens when we aren't able to describe that goal perfectly? How do we build a machine that isn't just intelligent, but is truly beneficial to us? That, right there, is the grand challenge that we are all exploring right now.